Assalamualaikum. Today, our group will present about final year project, which is optimization process parameters of preparation activated carbon for carbon dioxide absorption. There are two, Taguchi approach and Isotherm study. Our project under supervision Encik Muhammad SAUFI bin Mat ZAINI.
Assalamualaikum. My name is Muhammad HANIF. I would like to discuss about the introduction. Carbon dioxide. Carbon dioxide is a colorless gas. It has a slight unpleasant odor and a sour taste. Carbon dioxide is used by a plant to produce carbohydrate in a process called photosynthesis. Carbohydrate coming from burnt charcoal, gasoline, natural gas, and fossil fuel. In the industry, carbon dioxide can be recovered from flue gases and byproduct of the process. Although carbon dioxide is not the most potential greenhouse gas, it is a gas that greatly contributed to the climate change, which ultimately lead to the global warming. Nowadays, this problem has been recognized by many countries, and the CO2 protocol has been formed to reduce the carbon dioxide emission and the presence of the greenhouse gas in the atmosphere. Next, I will pass to the Hanisah.
Thank you, Hanif. Let's move on to the activated carbon. Activated carbon, or also known as an activated charcoal, is an absorbent. Carbonization and activation step are the most critical step for activated carbon production because these two processes will determine the mean surface properties and porous structure. The carbonization is the first stage and involves the formation of char because the volatile matter is removed. The example of volatile matter are hydrogen, sulfur, and nitrogen. It can be treated physically or chemically. The chemical activation agent used for our study is zinc chloride. The function of zinc chloride is to improve the rate of absorption. The activated carbon is a very significant feature of absorption because it provides high absorption capacity due to high surface area and porosity, well-developed porous structure, and strong mechanical properties. The structure of porous solid is random shape and has a different pore size. As you can see, we can classify absorbent into micropore, mesopore, and macropore. As you can see, this is the graphical image of micro, meso, and macropore in activated carbon. The size of micropore is less than 2 nanometer diameter. For mesopore, the range size between 2 until 50 nanometer diameter, and for macropore, it will be more than 50 nanometer diameter. The overall absorption process is the solute will diffuse from the gas to the surface, then into the pore, and finally to the surface of the pore.
Next, I will pass to NAILAH. NAILAH will explain about Taguchi.
Okay, I will continue with introduction of Taguchi. Taguchi is a method give a detailed understanding of the individual and cumulative effect of different design parameters on the basis of a minimum number of experimental trials. The Taguchi method uses systematic orthogonal array in the configuration of the experiment. The orthogonal array is a type of experiment where the columns for the independent variable are orthogonal to one another. The result of design experiment can be analyzed using both the analysis of variance, ANOVA, and signal-to-noise ratio, or SN ratio. So, the importance parameter that contribute to the process can be identified. The design parameters used in the Taguchi method are divided into different levels according to the response for each parameter to the performance measurement. The methodology is valuable when the design parameters are qualitative and discrete. In recent years, the dramatic rise in interest in the Taguchi method has led to various implementation of the method in a wide variety of industry and nations worldwide. Alright, this is Taguchi overview. There are 7 processes. First, determine the quality characteristic to be optimized. Second is identify the noise factor and test condition. Third is identify the control factor and their alternative level. Fourth is design the metric experiment and define the data analysis procedure. Next, conduct the metric experiment. Other than that, analyze the data and determine optimal level for control factor, and lastly, predict the performance at this level.
Assalamualaikum warahmatullahi wabarakatuh. Hi, my name is FARHANA BINTI MOHAMAD FAIZAL. So firstly, I will be talking about the problem statement. So for our problem statement, in the past decade, that carbon dioxide emissions have risen rapidly. Up to 30 billions of carbon dioxide enters the environment per year that is caused by human activities such as deforestation, burning of coal, burning of gas, as well as oil. So the increased carbon dioxide emission is a concerning issue that have largely contributed to global warming and catastrophic environmental impacts such as increased storm rate, flooding, and droughts. According to researchers, human activities have largely contributed up to 47% of the carbon emissions. And to debate this, there is a type of technology which is called the carbon capture technology. So what is carbon capture technology? It is shortened for carbon capture, utilization and storage or sequestration, CCUS. It is the type of technology designed to prevent the release of carbon dioxide emissions generated through a conventional power generation, and it can be stored. So the process of carbon dioxide reduction is by capturing them either by recycling or reuse to prevent further emission from being emitted into the atmosphere. So since this is a global issue, Elon Musk, who is a business magnate or industrial engineer and designer, who is famously known CEO and product architect of Tesla, tweeted on 22nd January 2021 that he stated that he is donating $100 million to US dollar towards a prize for the best carbon capture technology. So this tweet brought up attention to many companies around the globe that has already developed technologies that captures the carbon emission. So for example, LanzaTech has already developed technology that captures waste gas emissions and uses bacteria to turn it into usable ethanol fuel. So these include Climeworks and Carbon Engineering that already have specialized in direct air capture.
Thank you, Farhana, for the clear information about carbon technology. Okay, let me now turn to the objective of our study. There are 3. The first one, to obtain the conditions for the preparation of activated carbon for carbon dioxide absorption. Second, to develop the linear regression of carbon dioxide absorption. Last but not least, to study the Isotherm model, which is Lamouer, Freundlich, and Temkin of CO2 absorption. The factor we use is activation temperature, activation time, and impregnation ratio.
Thank you, Hanisah, for explaining the objective of this analysis. Next, I will continue with the methodology. The first methodology is the carbon dioxide adsorption by volumetric method. This is the procedure of the gas adsorption. The first step is the activated carbon sample were placed in high pressure stainless steel excimer cell to eliminate impurities at the room temperature for several hours. Next, 2 pressure transmitters were used to calculate the pressure. Continuous injection of carbon dioxide gas was carried out using the needle valve. And lastly, the number of carbon dioxide input mole calculated from the mass balance using application of the ideal gas law equation. This is the ideal gas law equation that I mentioned in the previous slide. From this equation, we can find the carbon dioxide uptake. Also, please note that we do not run this experiment. This procedure was conducted by our supervisor. Then we just put the data that he obtained into the Minitech 14 software. Next, I will pass this presentation to NAILAH.
Alright, thank you HANIF for your explanation. I will continue with Taguchi experiment design. In this study, there are three control factors, which are impregnation ratio, activation temperature, and activation time, with three different levels were used in order to achieve an optimized condition that will give high carbon dioxide uptake. The control factor and different levels shown in table 1. Second is NL9 standard orthogonal arrays as shown in design matrix of experiment and result response table 2 was provided by Minitech 14 software. The efficiency of the response is calculated by the accuracy of its performance in the Taguchi method. Usually, there were three major categories of the performance characteristic in the analysis of the SN ratio. First is smaller the better, second nominal the better, and lastly larger the better. As our purpose of this study was to obtain the value of response as high as possible, the larger the better of SN equation was used as follows, where Ni in the equation is the number of experimental replications and summation y over y square indicate the mean of sum square of reciprocal of measured data.
Absorption study. So for the absorption of isotherm study, a variety of isotherms have been applied in absorption systems where there are three types of isotherm models that we will use, which are Langmuir, Frendelich, and Temkin models. So for Langmuir, it describes the equilibrium between the absorbent and absorbent system where it describes the quantitatively the formation of monolayer absorbate on the outer surface of the absorbent. So in this context, which is the carbon dioxide on the activated carbon. So for the Frendelich, it describes the absorption characterization for heterogeneous surface, and lastly the Temkin discusses on the absorbent-absorbate interactions. According to these three isotherm models, we plot each on every one of it to observe which model suits the best for the carbon dioxide to activate the carbon for the best absorption. So for signal to noise ratio, the signal is the wanted value, meanwhile the noise is the unwanted value. And the term larger is better was used for our case of study as the carbon dioxide absorption was observed to be most desirable when it is at highest value. So the impregnation ratio was observed to be highest at level 2, which is 5.77. Activation at temperature at level 3, which is 6.9509 degrees Celsius, and the last factor, which is the activation time at level 1, which is 4.7791 minutes. So, according to this table, activation temperature, which is the delta is 7.9105 degrees Celsius, is the most influential factor affecting the response based on the delta difference among the other factors. So, activation time is the least factor affecting to the response since it has low gradient, which also indicates that there is no significant gradient observed through the graph.
I will proceed with a second finding, which is ANOVA. The name of analysis of variance or ANOVA is we want to analyze the variance of these three groups and to determine whether these three groups are significant or insignificant. The three groups which are impregnation ratio, activation time and activation temperature. The focus of this experiment is more to find the F value and P value. The F value indicates the statistical calculation on the effect of control factor to the response. According to the QB, the F value of more than 4 indicates that the control factors have a strong impact to the response. As the table shows, it is clearly that the impregnation ratio shows the F value with 4.59 and activation time 17.74 are the strong effect on CO2 absorption. Otherwise, for activation time does not give a strong effect on CO2 absorption because the value is only 1.4. Next, the p-value indicates the significance of the control factor on the response. The p-value need lower than 0.05, that for 95% confidence interval indicate the significance to the response. For our study, the p-value is almost significant to the response. If we use 90% confidence interval, the response will be significant.
Alright, for validation of optimum condition of carbon dioxide absorption, how we validate optimum condition? First is calculate the optimum level of control factor by using optimum predicted formula. Y is the total average response of all experiments run. A2 is the average impregnation ratio at level 2. B3 is the average activation temperature at level 3. And C1 is the average of activation time at level 1. All the response value can obtain from table 6, which is the result of prediction at optimum condition and comparison with other conditions. And this level get from result of main effect plus SN ratio. Our optimum predicted come out to be 3.33 mol per kg. Second is calculate confidence interval or CI by using CI formula and assuming 95% reliability. Our CI value is plus minus 6.414. After calculate with these equations, we will know the range of confidence level interval predicted optimal carbon dioxide. Our range is negative 3.084 and 9.744 mol per kg. Overall, optimization carbon dioxide absorption 95% reliable because our optimal response is 4.20 mol per kg in the range that I mentioned before.
Thank you, NAILAH. Next, I want to discuss about the development of the regression model. The linear regression model was introduced to establish a correlation between the operating parameters of activated carbon and carbon dioxide absorption capacity. Mean data for carbon dioxide absorption in various preparation variables were determined for the regression equation as shown below. The efficiency of the regression equation model was assessed in terms of the correlation coefficient value. This is actual against predicted carbon dioxide absorption graph. The value of R² is the variance between the result from the experiment and the prediction. This analysis revealed R² obtained at 0.6159, explaining that 61.59% of the experimental data is correlated with the predicted data. This graph shows the variation of error between experimental and predicted value in all experimental runs. This model standard deviation is 0.3234. The smaller standard deviation is better. Some of the data have higher standard deviation, which make the overall result not quite reliable, but still acceptable. As you can see, at the experimental run 5 and 6, it has the highest error compared to the others. Next, I will pass the slide to the FARHANA.
For our system study, first of all, understanding the interaction between the molecules. So for Langmuir, Prenderlich, and Temkin, there are three totally different interactions between the molecules. So the absorption equilibrium takes place when carbon dioxide surrounds the activated carbon for a certain amount of time, and the value of R square was used to determine the best fitted linear isotherm. According to the graph, the Langmuir R square is resulted in 0.5411, which is 54.11% from the experimental data. And for Temkin, R squared results in 0.9473, which is 94.73% from the experiment data. And lastly, for the Prenderlich, the R squared results is 0.9996, which is 99.96%, which is the closest to 100%. So according to the graph plotter, the absorption is non-ideal, reversible, and non-restricted to the formation of monolayer, meaning that the Prenderlich isotherm shows the best fitted, which suggests the heterogeneous of activated carbon, as the experiment data were the most fitted into the linear regression. So the low coefficient for a modeling indicates that the data does not follow the model, while a high coefficient means that it is the most fitted to the isotherm model. Isotherm is considered unfavorable when the separation factor is greater than 1, and it is considered favorable when it is greater than 0 but less than 1. The Prenderlich isotherm explains the behavior of absorption accurately. So in the equation of log QE equals to 1 over n log P plus log KL, the n is the constant that depends on the nature of absorbent and the gas at a particular temperature.
Thank you, FARHANA, for the clear explanation about the isotherm study. Next, I will continue with the conclusion. This study presented the Taguchi methodology is an efficient methodology for optimizing the activated carbon output parameters. This study analyzed by applying analysis of variance ANOVA for SN ratio larger the better. Optimum control factor. The optimum value of the impregnation ratio is 0.3. For the activation temperature is 700 degrees Celsius and activation time is 30 minutes. From these three, the activation temperature has the significant impact on the carbon dioxide absorption. The regression of carbon dioxide absorption that we get is 0.6159, explaining that 61.59% of the experimental data is correlated with the predicted data. The standard deviation is 0.3234. In the isotherm study, Friulich isotherm showed the better fit compared to the others. The regression is 0.9996, explaining that 99.96% of experimental data is correlated with the predicted data.
We have taken effort into this project, and it wouldn't be possible without the kind support and help from many individuals as well as organizations, and we would like to extend our sincere thanks to all of them. We are highly indebted to UiTM Bukit Besi as well as our supervisor Sir Muhammad SAUFI bin Muhammad ZAINI for their constant guidance, constant supervision, as well as providing necessary information for the completion of the project. Lastly, the support in completing this project. Thank you so much.
That's all from us. Thank you for giving your time for listening to our project.